Alright guys, now let us try to derive the function x power n with the first principles, where y is equal to x power n using first principles. Now, to completely understand this, you need to know one of the formulas of your first year PUC, which says limit of x tends to a, where x power n minus a power n divided by x minus a is given as n into a to the power n minus 1. Now that's a very important formula. If I don't know this, I cannot complete this problem. So make sure you know this. If you don't know it now, okay? Now let us see how to work with this. As I know that the first stage of the problem says what? Increase x as what? X plus delta x and y as y plus delta y. Okay, so it's the same three stages we're following. In the third stage, we may have to use this formula. We'll see how we can connect it later. I'll come back to this. I can write that y plus delta y is equal to x, instead of x I write x plus delta x to the whole power n. That's it. Now what is that I need to do? I need to make delta y on one side, that is delta y is here, and I put the y here. X plus delta x to the whole power n minus y. So what's the value of y? Delta y is equal to x plus delta x to the power n. Y is right here, that is x power n. Okay, now so it looks right. Now I need to make this fellow look exactly like this, that is x power n minus a power n x minus a. Is it looking like that? I have a power n and a power n here, but I have something missing down. So as the second stage says what? Divide both sides by delta x. Yep, that's what I need to do. And I told you in the last topic where I taught you what exactly is the frame of first principles, that I should not have this delta x in the denominator when I apply limits. Now what I do in this is I use a formula so that I can eliminate this. I may not cancel it directly, but I am using a formula. Look at this, what happens. Delta y by delta x can be given as, let us say, delta x plus delta x to the whole power n minus x power n divided by I have delta x. Now see, what is that formula I told you to remember? I'll write it here so that we keep it in mind. The formula was limit of x tends to a, x power n minus a power n by x minus a is a, that is n to a to the x minus 1. Now this has to look like this so that I can write the final step. But I can see that this and this are there, but I have only delta x. Can I add x here and subtract x? See, if I add and subtract, I get the same answer. It's legal in maths. See how it works. If I have 2, can I add plus, let us say I add 10 here and I subtract 10. So what happens? I get again 2. So I started with 2, I add 10, subtract 10, but again I can cancel this to get 2. So it means adding a number and subtracting a number is legal in maths, very simple. If I go with the same logic here, what I'm doing here is I had delta x, so I'm adding x and I'm subtracting x. So now it more looks like what? This guy is the first term, second term, second term. First term has got power, second has got power, denominator has got power. Now is it looking like this exactly? Not exactly. You have x here and I have x plus delta x here. Let me do one thing. Convert this, substitute x plus delta x as z. See, carefully watch this. What I'm trying to do, I am writing this x plus delta x as z. So what happens to my question? The question becomes delta y by delta x is what? Z power n minus x power n by z minus x. Now is this looking like that? Yeah, almost. Everything is same, right? But except for the limits. What is the limit here? Limit is x tends to a. But what is the limit I generally use? I use delta x tends to 0. How will I get that x tends to a? Well, let's see. Now, the third stage says what? Now apply the limits. Limit of delta x tends to 0, delta y by delta x is equal to limit of delta x tends to 0 only, and here it is z to the power n minus x power n by z minus x. Now, if I use this limit, in this case, if I write delta x is becoming 0, don't you think so x is becoming z? How? Let's let us see. If this guy becomes 0, then what happens? X becomes z. So if I delta x is becoming 0, I can simply say from this that x, let us say, it says x plus 0 is equal to z. It means x becomes z. So if this is becoming 0, I can say x is becoming 0 or z. So can I write the same thing there? Can I write if delta x becomes 0, let me change the limits as z tends to a, z is becoming x. So I can write z is becoming x. That's my limit. I hope you understand how I got z tends to x instead of delta x tends to 0. If not, I'll explain once again. Look at this. Here what happens is this. This what is my substitution, that is x plus delta x is 0, is z from here, right? Now if I say that limit of delta x is becoming 0, is delta x is becoming 0, it means this guy is becoming 0. So what happens? If this guy becomes 0, x becomes z, right? If it is 0, if it is becoming 0, I can say that z is becoming x, right? So it is tending to x. So I can write if limit of delta x tends to 0, I can say that x tends to z or z tends to x. Now this is what I am trying to take here. I am changing my limit. The left hand side it is delta x tends to 0 itself, but on the right hand side instead of delta x tends to 0, from this logic I can write z tends to x. Then I can write z power n minus x power n by z minus x. Get that logic? It's very important. Limit of delta x tends to 0, delta y by delta x. Now in the third stage, I can write this as well, dy by dx. Very simple. And on the right hand side, if I use this formula, see, look at this, limit of x tends to a, is z tends to x power n, z power n, a power n, x power n, z minus a. So I can see that on the right hand side, the x terms here are not involved here only a terms are involved. See, a is here and this n is here, n minus 1. So it means the second term is only important for me in the formula. It means here the second term is x, this guy is important. So it becomes n into x to the power n minus 1. That's all, isn't it? Right? So it is a very simple thing. And what is that you need to know here is this formula, one thing. And after I come here, I make this guy look like that formula, substituting this as z. The third thing important to remember is how does I apply limits. I apply the same limits, delta x tends to 0, delta x tends to 0, but this limit here should almost look like that. If it all doesn't look like that, I can use a formula. So in that case, I use this logic, that if at all delta x becomes 0, x should become z or z should become x. So I am taking a limit as z is tending to x as delta x tends to 0. So that's very important. After I come to this, I use the formula.